Welcome to the Packaging Therapist Podcast, the show where we discuss technical packaging problems so that you can solve them for your business. All right, everyone. Welcome to the Packaging Scholars Podcast. Today, I am joined by Andrea Ochter, who works for NatureWorks. I'm going to give her a second here to introduce herself, and we'll get into it.
Thank you, Jesse, and thank you for having me on the podcast. My name is Andrea Ochter, and I'm a manager of applications development for NatureWorks. NatureWorks is a leading supplier of the biopolymer PLA called Ingeo. And so we make PLA and we sell it into many applications. I've been with NatureWorks for 4 years, and prior to that, I was with General Mills. And what we do in applications development is we help converter partners to use our PLA Ingeo in their equipment and kind of optimize the processes, help whenever there's things that need adjustment, and recommend settings.
Fantastic. And let's dive a little bit into now the rigid plastic itself. Can you tell us a little bit more about what can you do with this polymer? I know there has been a ton of change in the industry, even in the past couple of years, where this material performance is much better than it has been in the past. So maybe you could speak a little bit about, how people could think about using the resin.
Yes. Yeah. So nature makes things from CO2, and so do we at NatureWorks. So plants are sequestering carbon dioxide and converting it into sugars, and then we can take those sugars and ferment them into lactic acid. And that's the building block for the biopolymer Ingeo PLA. So that PLA then can be used to make many applications, food serviceware with clear rigid thermoform containers that we'll talk about today, as well as other applications like 3D printing, tea bags, and fibers.
Wow.
Yeah, and so we've been in the market for 20 years with our 2003D Ingeo PLA grade for clear thermoforms. And what we do to help enable people to run is ship in dried barrier packaging so that because PLA resin, you need to dry. If you don't dry it, you'll have degradation in your extruder. So you dry it to get all the moisture out, and then you can extrude it, and you will maintain the quality of the PLA through your extruder. So we ship it dried in barrier packaging so that if you don't have dryers, if you don't have that capital equipment, you can still test out of the box to understand if Ingeo is going to work in your system and equipment. But then long term, you'll want a capital plan in place for drying and crystallizing depending on your application to run that Ingeo the best and most economically as possible. Other things to think about in running Ingeo for extrusion and thermoforming are you might want to consider longer term a screw design. PLA is a thermally sensitive polymer. So as it experiences more shear in the extruder, it gets hotter, and that can lead to degradation if it gets too hot. So a simple solution is slowing down the line. But that's not preferred by most converters. So, you can test it at slower rates just to make sure that it's working in your end application in your converting system. But longer term, to really get those rates that are desired, you will want a capital plan for PLA.
Okay. Yeah, that sounds good.
And what's great about using PLA in rigid containers is that often those are used to contain food, deli containers, takeout, beverages. And the great thing about PLA is it's got really good stiffness properties. So you can lightweight sometimes, use that stiffness of the PLA. It has crystal clear clarity, so you can see everything that's inside of it, whether that's grapes or a drink. You want to be able to see that lovely food that you're eating. And then when it's food soiled, there's many end-of-life applications. You can industrially compost PLA, so you can capture all the food residuals that are in that material, in that package, and put it in compost. It can be cleaned and then mechanically recyclable, or it can be chemically recyclable back to the monomer.
Oh, wow. Okay. Do you know if there's any current systems in place to recapture versus industrial compost, or where do you see the future of reclaiming
Mm-hmm.
that?
Mm-hmm. Right now, certainly industrial compost seems to be what is most available to people in terms of land mass and locations.
Mhm.
As chemical recycling grows in popularity, that could be a really good option as those systems come up into place. I'm not aware of a lot. There's a few partnerships I've heard of over the years, but I don't know how commercial they are yet.
Sure. But I guess what matters at the end of the day is that this can be recycled.
Yes.
Yeah, which is really cool. I didn't know that. So then, as we think about the different applications and the different pieces and types of things you can make, or your converters can make, can you talk a little bit about options? I know you said rigid containers for like deli applications or silverware. I think I've
Mm-hmm.
seen straws. Have we missed any?
Did you say straws?
Yeah.
We're not typically in straws. We were a few decades ago, but
Hmm.
more that is we've moved away from that. So I'm not aware of straw
Oh, okay.
applications right now. But yes, so clear containers. We also do cutlery. PLA will be found
Yep.
in cutlery as well as extrusion coating. So coating it onto paper that can be formed into hot cups for coffee or cold cups. Hot
Oh,
coffee lids are also made from PLA. So those are a lot of the applications in food serviceware that I directly support.
cool. So then, if somebody's interested and they kind of want to know ahead of time, like what type of cost could they end up spending? Like, is it more expensive than a PET or a
Mm-hmm.
other type of plastic container? How does it compare from a price standpoint and an investment standpoint?
Yeah, so biopolymers are typically more expensive than conventional polymers, at the face value of the raw material.
Yeah.
One benefit that you get with Ingeo is that because we're made from plants, there's a better carbon footprint to convert. So to make Ingeo, there's actually a less greenhouse gas emissions and
Mhm.
less energy from non-renewable sources used. So you're already improving your environmental footprint by switching to a biopolymer. And then, as well, our PLA processes at a lower temperature. So on the
Okay.
converting
Oh,
side, you don't have to heat up your equipment as hot. There's energy savings on the converting side because we process at a lower temperature.
yeah.
So it's really important to look at the whole picture in terms of cost.
Yeah, absolutely. Um, and when you think about production, is is it different? Does it run through the equipment differently? We talked a little bit about drying it, right?
Mm-hmm.
We talked a little bit about shear, but is there anything else to consider when you're running this material?
Yeah, so you definitely want to make sure that we're not overheating the PLA. When we're overheating it, that can lead to degradation, as well as we want to make sure that we're drying the PLA so there's no moisture in there. If there's moisture, that can cleave the polymer bonds and degrade the polymer.
Okay.
So those are two important things. And a great way to measure your temperatures is to have a melt immersion thermocouple. And that way, as you're extruding the PLA, you know directly in the stream what is that
Hmm.
melt temperature, which is typically for PLA hotter than your metal temperatures because it's a shear heating polymer.
Yeah.
So those are really important considerations. And then making sure that you are having a screw design that's low shear,
Hmm.
as well as trying to build flexibility into your process. And then there are, you may need to consider some things because Inzio is so stiff, you
Hmm.
may need impact modification to help get the final properties of your articles that you're looking for.
And when you talk about degradation, what type of defects show up if you're using too much heat?
Yeah, so if you're having degradation from too much heat, that can show up in discoloration, so like darker color product,
Hmm.
more browning, yellowing in the product. It can show up as more neck-in, so loss of melt strength. Instead of a really uniform and strong melt curtain, you would see sagging in your thermoforming process. You would see a more
Okay.
narrow web, or as opposed to what you typically would experience, a
Hmm.
nice wide web. Those would be, yep.
Okay, so the defects would happen before the part was made.
Yeah,
Basically,
you
you'd
would be able
better
to
know.
observe before the part was made.
Sure. So if you're using a rigid container in production, right? You've purchased NatureWorks thermoformed cups. Is there anything people should consider when they think about swapping out the plastic rigids they have in terms of denesting or running down the line, or maybe if, any
Yeah.
type of physical
Hmm.
properties like fracturing, differences in those types of properties of the packaging?
Certainly, an important one for thermoformers is going to be mold shrink. So, the mold shrink for PLA is going to be different than PET or polypropylene,
Okay.
and really needs to be taken into consideration. So, some equipment is a little bit easier to run on, or a little bit closer to the needs of PLA,
Hmm.
where polypropylene, the shrink is a lot different than PLA. So, that would probably mean a different mold cavity um, to get your same part dimensions and tolerances that you need. But in terms of then punching out and stacking, that's pretty much the same. You
Okay.
do need probably some D-nest to help those stacks of parts come apart easily, depending on your application. If it's a really wide, shallow, perhaps not. But if it's a deep draw type
Yeah.
application, then definitely we've seen that help a lot.
And any issues with static buildup or anything like that?
Yeah, you do need to have grounding, even touching the web after it's formed.
Yeah.
Definitely some, yeah.
Yeah. Cool. Then talk a little bit about, like, let's say it's food contact. You've got a cup. You've applied lidding film. How does shelf life compare, and like the moisture and oxygen transmission rates? Um, how do
Mhm.
they compare?
Yeah, it really depends on your temperature as well for PLA. So if you're in a cold, refrigerated, or frozen environment, the
Mhm.
moisture transfer properties change significantly for PLA. They're much better than, say, a room
Okay.
temperature application. And once you're at the thickness of a rigid part, your moisture barrier is going to be good enough for shelf life. It's
Mhm.
not as good as some other conventional polymers, but in terms of keeping your product safe, absolutely. If you have, moisture sensitive product in a thin film,
Mhm.
where you typically might have a metallized film pouch application, you would still need that metallization layer to get those barrier
Right.
properties to keep that dry food product edible and good flavor and all that.
Sure. And then in thinking about films, then is there anything you want to add about film applications? Because we've mostly spoken about thermoformed parts.
Hmm. Yeah, so we want to do a whole another podcast on film applications,
Oh,
and I'm looking forward to that. Definitely stay in touch with strategic packaging partners to get the next episode on films.
perfect. And then, is there anything else you want to add? We've talked about how you guys make the resin. We've talked about how there's converters out there. If people have questions about kind of where to go, either they're interested in like making parts, or they're interested in using new material in their system, where can they go? And anything else?
Hmm. Yeah, yeah, we would love to connect with people. We have a great website, natureworksllc.com, where we have a system you can put in an inquiry for samples, and that will get you connected and routed to the right resource for your application. So I highly recommend checking that out. I do think it's worthwhile to touch on what does compostable mean briefly. Because that is one of the advantages that you're bringing with PLA, besides the other beneficial properties like stiffness and clarity. So, compostable, you can get certifications on what is compostable. So there's ASTM standard D6400 is the typical one in the US.
Mhm.
And it's a standard about how fast does your polymer disintegrate? That's kind of one question. And then
Sure.
another question you have to ask as part of that is my material available as a food source for microorganisms that actually can eat it and break it back down into carbon dioxide and water? And so they're both important because it's not enough to just break down into small pieces. It needs to be a food source for the microorganisms and actually being taken back to molecules so that
Right.
it's, totally circular. And
Can't
so
turn into a
that's
microplastic.
exactly.
Yeah.
So we have certified several of our NGO grades to ensure that they comply with the BPI certification for industrial compostability. And then also we've been hearing a lot about home compostability. We know that's coming. There's not a
Mhm.
certification yet in the US. So more to come on those development efforts.
Yeah, so then the backyard compostable certification is different in terms of temperature needed to break down and time needed to break down. I've actually seen like maybe the time's a little bit longer, but it's
Mm-hmm.
that high heat that you need for industrial compostable resins. That's kind of
Yep,
tricky because the backyard doesn't quite get hot enough for the right duration, right? So that'll be really exciting to kind of get into that space. I think that's what everyone's really excited about, right?
I do
Um,
too.
it's not confusing
And
as
there's not
confusing.
just it's not just thinking about end of life only certifications. NatureWorks has gone out and certified several parts of the value chain. So we have USDA certified bio based. So even just moving away from fossil based plastics to bio based plastics and other materials is a big step towards a circular economy. So that's something to think about too with beginning of life, as well as being sustainably sourced feedstocks, ISCC, as well as just product health and safety. So Cradle to Cradle, we're certified gold, and Green Screen, which is looking at toxic chemicals like PFAS, we achieved
Mhm.
their platinum level on 2003D, which is the highest level of certification you can get to be totally non-toxic, nothing bad in there, no
That's
impurities.
fantastic. Congratulations.
Thank
That's an
you.
achievement and one that we really need in the industry right now.
Yeah.
Um, so fantastic. Well, thank you for joining me today.
Yes, thanks for having me.
You're very welcome.